just like before when discussing prevalence and incidence, we should also take time to consider some issues with association and the ways that we communicate it. Communicating associations is actually quite difficult in a way that, and we can make it more difficult than it actually is, especially for the reader to understand what it is we're trying to say. So this is something you could find in a paper. The 5-year risk in the exposed was 10% higher than the 5-year risk in the unexposed. What are the authors trying to say? How do we interpret this? Do they mean that was there a 10% risk difference? So does 10% higher in this case mean a risk difference of 10%? So it's 50% versus 60%? Is that what they're trying to say? Or is it supposed to be interpreted as a ratio? Is it a risk ratio they're trying to interpret? So it's 50% versus 55%. The moral of the story here is to always include difference or absolute scale or percentage points if it is the difference you are reporting. So 5-year risk difference was 10% higher, or 5-year absolute difference was 10% higher, or 5-year risk was 10 percentage points higher. We would expect to see 10 more cases per 100 people, and so on. So just be absolutely clear which measure of association you are intending to communicate. If it is a ratio, then always include the word ratio or the times the risk. So the 5-year risk ratio was 10% higher, or the 5-year risk in the exposed was 1.1 times the risk of, and so on and so on and so forth. This is very important, and I feel like I see this a lot of the time, and it's hard to sort of understand what kind of risk measure are you trying to convey. Which measure to use? Well, the short answer is that the risk difference is the most clear message, and I think I said that before. So if you can communicate something like, if we implement this new policy, we will reduce the absolute risk by 10%, i.e. an additional 10 in 100 will survive. I think that's a quite clear and easily understood message. The risk ratio, on the other hand, might sometimes send a stronger message, and that's why I see it sometimes abused, because it can be misleading. So what if I said being exposed to factor X doubles the risk of disease Y? That sounds pretty bad, but consider these two examples. The non-exposed risk is 10% and the exposed risk is 20%. This gives us a risk ratio of 2. Okay? But so does this. If the non-exposed risk is 0. a lot of zeros 1%, the exposed risk is 0. a lot of zeros 2%, that also gives us a risk ratio of 2. But these are not necessarily risks we care about, right? The difference between these two really doesn't matter, but the risk ratio is still high. This is obviously an exaggerated example, but you can see this in ways that scientific publication tries to make their results more aesthetically pleasing, in the sense that they can say that, oh, the risk is twice that of the unexposed. Try to always use the risk difference where possible. Now, there are some old friends we should revisit. You should consider all the limitations or the considerations that we discussed when looking at prevalence and incidence, so go back to them and remind yourself. There may be local and cultural differences which affect how different groups are measured. That should be remembered. So if we are, for instance, comparing exposure, or let's say just being a university student in Great Britain and in Sweden, and then we're going to use a cohort in Great Britain and one in Sweden. That's how the contrast that we're going to compare. Then if we measure things differently in Great Britain than we do here, then that's going to be an issue here, okay? And maybe it's as simple, it might not be that extreme. It could just be that different clinics measure things differently, and therefore you also get different results, okay? So sometimes the contrast of two groups might be due to different measurements rather than an actual difference in risk. Definitions can change over time. You can have new technological developments, new biomarkers. We discussed all that before, so those are always, we should consider them still. Systematically missing data, big issue here as well, obviously. If one of the groups that we are studying, let's say the exposed group, have data that is missing systematically, and then the unexposed group has data that is missing systematically but in different ways, that creates layers of attrition bias issues that should be dealt with. So the old friends still apply. There are new friends that apply here. Similar distributions of factors in groups being compared. So if you are comparing some contrast, an exposed and an unexposed group, are they otherwise similar? Or perhaps is the exposed group also older? But you didn't intend for that, but maybe it is due to the way the cohort is designed. And therefore you might see risk differences that are not due to the exposure, but just due to the constellation of the groups being different. Another thing to consider is, should you pick a completely non-exposed group as your non-exposed group if there is a somewhat exposed group which is larger? So it's, for instance, very hard to find people who have never been exposed to secondhand smoking. Okay, so saying, oh, I have a cohort and one of my groups have never been exposed to secondhand smoking, they have not been exposed. That's going to be difficult. So maybe you have to do a different cutoff and say, well, limited. They shouldn't have a relative who smoke or something like that. Not exposed daily could, for instance, be your definition of unexposed. Exposure is often continuous, so blood pressure, number of units alcohol consumed, weight, and so on. And as far as possible, I mentioned it before, we should keep them that way. If something has been measured continuously, then it contains a lot of great information, and we want to keep it that way. Once we start dividing it into categories, we lose information. However, it is common to come across methods to create dichotomous exposure groups, or just maybe not just dichotomous, but also multinomial exposure groups. And these are some of the examples you might see, which I'm not super fond of, but we do use them sometimes. A median split, you're basically just saying, I'm going to compare the people. These guys are unexposed, these guys are exposed. That's one way of doing it. You are maximizing the group size. Everybody can be part of your study. You are minimizing the contrast because these individuals here and these individuals here are going to be very much alike, and therefore you might not see a big difference between your two exposures. You're going to have a lot of borderline cases. You're going to be underestimating the risk. And as I said, you're going to throw away a lot of good information. You can use the extremes, so only individuals here are considered exposed and only people here are considered unexposed, or the other way around. Now you're going to minimize group sizes because these individuals can't be part of your study anymore. But you're going to maximize contrast because you're expecting these people to have very much different risk. Then what do you do by borderline cases? Well, you just decided to cut these away, and that's why you're throwing away some information in that sense here. And also generalizability, because now your study only applies to the extreme, so your findings don't apply to the general population here. You could also do multiple categories, so you could divide them into not dichotomy like that, but actually have multiple categories like this if you wanted to. Some groups might be small. You're going to have a big group here and a big group here, and you're going to have small groups here, small groups here. If you have measurement sensitivity errors, then somebody who's supposed to be in this group might end up in this group just because an error of measurement. And I guess that's also true of the other cases here. And it does throw away information. I think I've made my case clear that I think that you should keep variables continuous if they are continuous. But I also know of study designs and some topics of research where this is necessary. Just think about, I just want you to think about this if you're forced to do it. And don't do it by convention. I think that's the worst reason to do something, because somebody else did it before. That's probably not a good idea all of the time. Sometimes it might be a good idea. Okay, finally, my last consideration here is the prevention paradox. If we want to reduce the overall cases of alcohol-attributed injury, how do we do that? Okay, I know that the prevalence of alcohol-attributed injury is higher among risky drinkers. So the prevalence rate is higher among risky drinkers. But there are more cases among non-risky drinkers. So look at this. We have non-risky drinkers here. We have risky drinkers here. There are 12 cases of injury among the non-risky drinkers. There are 4 cases of injury among the risky drinkers. The prevalence proportion is 36% here, and the prevalence proportion is 44% here. What if I did an intervention? So the overall prevalence of alcohol-attributed injury is 38%. If we put these two together, two groups together. Now I could choose to intervene among these guys, or I could intervene among these guys. Hopefully we would have the resources to help everyone, but we could also say, well, we can only help one group. If I intervene and remove all cases among risky drinkers, if I intervened here, then that reduces the overall prevalence of alcohol-attributed injury to 26%. The number of cases is reduced to 26%. But if I intervene here and I remove all cases here, then it's reduced to 9%. This is sometimes referred to as the prevention paradox, that we know that the risk of a certain disease is higher in one group. But when we look at the overall number of cases, it might be better to intervene in a lower risk group. But that's not, I should say, I mean, this is a phenomena that we should be aware of, but this might not always be the best sort of initiative to always just think about how do we reduce the overall number of cases. We should help everybody as far as possible. We should help everyone, right?